Alright lads, today's drawing, the 2014 question 1. It's timber frame drawing, and we'll just try and take you through it here as quickly as possible. Right, there's nothing new from the what I've given you in the last couple of days, so let's just bang on with it. First thing, we'll read the question there. Sketch shows, here I'll throw it down here. The sketch shows portion of the roof and external wall of a single story dwelling house. The house has an internal span of 6 meters. The external wall is of timber frame construction. So if it has an internal span of 6 meters, right, I'm going to draw a line down there from the verge of the roof and bring a line over there. So if that's internally 6 meters all the way across, that's 3 meters here. Write that on it straight away. It has a 200mm timber frame inner leaf. That's different to what we've done in our drawings, right? It's only a difference of 50mm. Just make sure you have it in your drawing now. And a 60mm insulated surface cavity. The roof, which is slated, has prefabricated truss rafters and is pitched at 30 degrees. So you need a 30 degrees set square for this fella, okay? To a scale of 1:10, draw a vertical section through one external wall and one rafter length. Now, one rafter length, that's the reason why I'm after figuring out what the distance halfway is. So it's 3 meters, right? That's why they give you the 6 meter span there. Show the typical construction details from 400mm below the ceiling joists through the external wall and eaves up to the ridge level. Include the ventilation path to the roof and show 3/4 slates at the eaves. Include 3 typical dimensions of the roof structure, right? The roof structure, but we'll put the dimensions of everything on it anyway. Indicate clearly the design detailing to ensure airtightness at the junction of the ceiling and the external wall, right? That's part B, and we'll deal with that there later, alright? So I'm going to bang on there with it and I'll talk you through it, okay? So this drawing doesn't mention anything about a foundation, so we don't need it, right? So if you do a foundation in this, you get no marks for it. Wasting your time. So I'm going to go down to the left hand side of my page here and start my drawing, right? They said 400mm below the ceiling joist, so I'm going to draw that line up there, 400mm, and get this thing going, right? So if that's my position of my ceiling joist, I'll draw my ceiling joist over this way. Start banging in the wall. Right, so my wall is, it told me it's 200mm wide, right? We've drawn one 150mm. There's nothing different about it really except the size of it. Down in the foundation, however, it would have a different, it would have an impact on it down there, but that doesn't make any difference to us in this question here. Instead of a 6x2 at the top here, where you have the head plate, now you're going to have an 8x2. Yeah, an 8x2, yeah. So we'll just put in one there, make sure it's a double one, double head plate. Draw it in nice and neat there. Get your X across. The X, all that means is it's made from timber. And now we've got marks already. To be fair, every correct component you draw, you get 4 marks for. Right? So I mean, technically that's a correct component. That's a correct component, right? The double head plate. So there's 2 correct components there. This wall is drawn the correct size. And once it's labelled and things like that, it'll be correctly drawn, okay? On the inside of our wall here, the internal wall, we're going to put in our OSB sheeting, and I'm going to put it in there maybe at 12mm or something like that there. So there's a sheet material. Sheet material is basically a layer of chipboard, and you know, needs to go in there. Green biro, I'm going to put that in for our insulation. Now our wall is starting to take a bit of shape. On the inside, sorry, on the outside of the wall, I'm going to put my breather membrane. I'm going to put that in blue. On the inside in red, I put a red layer there. That's my vapor check. Does it tell me what size of cavity is there? Doesn't mention the cavity, so I'm going to put a 50mm cavity there in between the walls, and I'm only going to draw the bottom portion here of that wall. And I'm going to put an outer concrete block. I assume it does, yeah, rendered concrete outer block, 100mm wide, and I'm not going to go up all the way. I'm not going to finish off that concrete block. We'll see why in a minute. On top of the, so where does the roof attach on here? Let me just put that down. Where does my roof attach? My roof attaches here at the top here. Okay, so that prefabricated roof truss, it just comes and sits down on top of the roof. Okay, so it's dropped off the side of a crane. Now it doesn't need a wall plate, it attaches directly onto it. It doesn't need a wall plate because, well, I suppose this already acts as your wall plate. Now I'm going to go straight through the corner of that piece of timber there, straight through the corner of that there, and that will give me the point of contact for, what's that, the outer wall and all that kind of stuff. It tells me in the question that the internal span of 6 meters, right? So 6 meters is obviously, you know, 6,000 mil. Divided by 10 is 600, and in our page, in our drawing, we need to show one full rafter length, so we need to go across here 300 mil, and 29, 30. I just about have enough room on the page. Now in the exam you will get a bigger drawing sheet than what I have here in front of me, but that's not the end of the world. Okay, so the size of the rafter, does it give me size of a rafter? No, it doesn't, so we're just going to assume it's 150. And draw it right up to the edge. Draw our ceiling joist right up to the edge of the rafter. Okay, so that's our ceiling joist put in there. Now I'm going to put in some insulation. I'm not going to go the whole way across. Or do you know, I'll leave it for another while. Our rafter now, right, we want to measure the size of our rafter, so we'll use our 60-degree set square there, draw a parallel line or a perpendicular line straight out there, and measure along that line 150. Now I can continue those two lines up, and that will give me the full length of our rafter. Until it meets up there. Yeah, sure, we're just about there now, yeah. I'm just about going off the page, but anyway, it looks fine. So there's my rafter drawn in, and I have a full length of the rafter there, the full section view. Now I would have a ridge board up here, but I'm actually not asked to draw it in the question, so you know what, I'm going to leave it out. Okay. Now I can see why I didn't finish off my blocks on the outside, because, well, I didn't really know where it was going to finish off. So I'm going to bring it up there. We're not going to touch it off. We're going to leave a bit of space there. And now I can finish off my little detailing there. Get my red biro. Close that cavity. Okay, cavity closed. Now, if I want to be, I suppose, a little bit overcautious, I could extend my lines down here a little bit more, but it does say only 400 mil below the ridge level. But if you want to extend them down just a bit, you're more than welcome to do it. Now I'm going to add in some details here. First things first, I need to add in some fascia and soffit. Our fascia is 25 mil fascia, our soffit is 12 mil. What we could do is we could just go straight out here. And cut that there. I'm not giving you a particular overhang. Just as long as we're down. Do you know what now? I'm going to go down further. But I am conscious that I'm getting close to the edge of the page. Yeah, it's better. I wanted to hang down a little bit further down over the edge of the concrete blocks here. Okay. That'll do me. Now I can add in my fascia. What did I say that was? 25. So 1, 2, 25. Go down a bit there, 25 mil. Bring that in there. I'm going to leave space here. That's for ventilation. You're ventilating the eave. Very important that you have ventilation. And I'm going to extend that up just ever so slightly there. Okay, so I have a fascia and soffit on now. Now I also need a timber here and some sort of a batten, and I'm going to put that in there, maybe 30 mil or 25 mil, and that will go up along the wall there. Right, so we're almost ready. I'm going to add in a gutter, almost ready to start roofing. Or start slating even, should I say. I just drew that in freehand there, and I might even put a bit of a design on it. Yeah, lovely. So the first things first, anyway, we need to put on some felt onto our roof. Weatherproof it. Tilting fillet, piece of timber, and my felt. I'm going to do that in blue. And I'm going to extend that just about into the gutter, and we'll start putting on some battens. Now the first one, we have 3 courses of slates at the eaves. We've 2 half slates, or 2 short slates, 2 cut slates. They're not quite half, and then the third slate is a full slate. So the first one, is 250 mil long, but we want it to extend into our gutter about 50 mil. So the first one will actually be 200 back. So we'll measure back 200, and that's the position of the end of the first slit, right? So right here is the position at the end of the first, or the first batten, should I say. So if that's the position at the end of the batten, well then the batten has to go back down here so you have something to nail into. So it's a 50 by 25. So there's 50 wide and 25 high. Now just to make things easier for myself, I'm going to draw a light line all the way up along that I can measure. You may or may not be able to see that on the video, that I can measure all my battens up to this line. So there's my first batten. The second batten, or the second, that one is 250 mil long. Just leave it sticking in there. The second slit is 350 mil long, so that means that it's 100 mil. It's 100 mil longer. So from here again, go back 350 mil, that's to the back end. We'll go 50 mil wide. And then draw in our slate, which is 350 mil. Okay, so there's two slates I've drawn in. And the third slate then is the full 600. So I'll draw that. I can actually draw the slate before I draw the batten if I like. And add in my batten. Now once you've these first three slates drawn, everything else is simple. Because it's just copying it over and over and over. Okay, so what we'll do is there has to be an even spacing obviously between the battens, and that spacing is 250 mil centers. Okay, so center to center 250 mil. I'm not going to go center to center. I'm going to go the first point here to the next first point here to the next first point to the next first point. Okay, so 250 mil. 1, 2, 3, 4. Now it only asks me for how many courses? For 3 courses. Normally only asks you for 3. So I'm going to give him 3. But I'm going to draw a few extra battens there just so you can see, just so it refreshes for you how it's done. Tops of battens there. And remember, 600 mil slates. So I'll go to the back of the batten there and let it sit on top of the next one. Hold it up along until you have at least 3 courses of slates done. Now I have 1, 2, 3, 4, 5 courses of slates, more than enough for this question, right? So we have a few more things to do in this question. We have the Eave's ventilator. Well, we have that drawn in here, and we also need to have or ventilation going up into the attic. Okay, so I'm going to put in my ventilation there. Make sure it goes right up into the attic, past where the insulation is going to be. So I'm going to just extend it up there a nice bit, exaggerating it. And I'm going to put a green arrow there of air. Okay, so that's my airflow. Other than that, I'd say we're good to go. I'm after making a mistake there now, but I must rectify it straight away. I'm going to extend this fella up here a bit. This timber now I'm talking about, not the concrete wall, obviously. Right, I'm going to extend him up there just a touch. And now I'll be able to put in my insulation, because if this timber wasn't extended up above the top of the wall, this insulation would be able to fall away from the inside of my wall, and look, you're just asking for gaps for air to be able to leak out. Okay, so first thing we'll do is we'll fill in this section here with insulation up and around the corner. You see how my ventilator is keeping that space for air to be able to move. And you continue that along the far side. No, it's not enough, because as you know, the insulation inside and in between the joists is only in between the joists at the moment, and you still have a path for heat to be able to escape going straight up through the joist. We don't want that, so we'll put an extra layer of insulation going on top of our joists here, an extra 150 mil, and that will sit on top of those joists there. And we'll put that right out. The rafter as well. Now this ensures that you have absolutely no way for cold bridging. Right, we'll leave that there as well. You continue that line the whole way across as well. Underside of our ceiling joist, we will put onto a 12 mil plasterboard, 12.5. I'm going to put it in black now, but normally it's not in black, but I'm going to put it in the corner here. Air tightness tape. Sorry, I'm wrong. I shouldn't have done that. In the question, are we not asked? There's a 60mm insulated service cavity. Right, so we were talking about that the other day, weren't we? So we can put in that there. Insulated service cavity. And put my plasterboard outside that there. Insulate that then. And we are now airtight, right? So we're airtight here. We've our insulated service cavity here. We can still puncture this without having the fear of ruining our air tightness, because we have our air tightness guaranteed up here, and with the vapor check, right, that guarantees us our air tightness. I think that's pretty much it. we have to indicate 3 typical dimensions of the roof structure. So when you're doing your labelling, that will be it. You'll be able to do it up there, 250mm centre, 600mm by 300mm slate or something like that, 150mm by 50 rafter, 150 by 50 ceiling joist. Whatever you deem necessary yourself, you could fascia and soffit if you wanted. There's loads of things there that you can, the 50 by 25 batten. There's loads of things, as I said, that you could label to make sure you get your 3 typical dimensions, you get your marks, right? In higher level construction studies, you need to have 12 points or 12 elements in order to succeed here, right? They need to be correctly drawn, they need to be labelled, and need to be the right size. Okay, so if you hit those 3 markers and you have 12 elements, you should be laughing. All right. Part B, it says indicate clearly the design detail to ensure air tightness at the junction of the ceiling and the external wall. Okay, so we have it here. That's part B. It's not good enough just to have it in your drawing. You must indicate clearly. Now, I don't think you can indicate clearer than that, but if you draw it and you don't indicate clearly, you're not answering the question. So please, for the love of God, if you go to the hassle and the bother of drawing it, just show them, okay? Anyway, that's this drawing. Hopefully this helps get this drawing done. I know you don't have drawing equipment at home, but if you can do it in a sketch, that'd be great. Thanks very much, lads.